Hi, everybody. It's Miss Rose. Welcome to fourth quarter. We're going to be talking about area this week for week 28 and the next few weeks to come as well. The area of a shape is literally how many squares fill up that shape. So that's why when you talk about area, you use square units. So you might hear people talk about how many square feet their house is. They're talking about area. So let's talk about a few basic shapes like a rectangle, for example. So this one I put on a grid so that you could really see what I mean about the number of squares. So if you have 1 by 1 squares and you have 8 in each row and there's 6 rows, then the easiest way to calculate the area is to just say 8 times 6. Your other option is you could literally count every single square and you will get to 48, but it will take you a lot longer. So you say that the area is 48 squares or 48 square units. I'm going to write it like units squared. What if you have a parallelogram, though, instead of a rectangle? All of a sudden, when it comes time to count squares, it gets a little bit more complicated because you have squares that aren't completely filled. So one good way to think about it, I found this animated GIF that we're going to look at, is if you take that triangle and you move it over, a parallelogram really isn't any different than a rectangle if you rearrange some of the pieces. So if rectangles area, if you can just go base times height to find the area for a rectangle, then we can do base times height to find the area of a parallelogram too. So if you moved this triangle over here, you would just have a rectangle with a base of 8 and a height of 5. So I'm going to go 8 times 5, and that is 40 squares or 40 square units, 40 units squared. And then the last shape that we're going to look at is, how about a triangle? How do you find the area of that one? So you've probably learned before what the formula is for area of a triangle, but I want to take a look at why. So I have one more animated GIF that we're going to look at. And that is, what if you take a triangle and you duplicate it, and you take the clone of the triangle and you rotate it around. I don't know why this is so slow. And you put them together, you get a parallelogram. So if a parallelogram is base times height, a triangle is just half of that. So you've probably learned a formula before, either 1/2 base times height or base times height divided by 2. So let's look at what the base actually is, because this one doesn't have numbers on it. So how many boxes is this? 1, 2, 3, 4, 5, 6 boxes for the base. And then for the height, let's drop an altitude straight down from that vertex at the top, and that's 2 units long. So I can do base times height, but then I need to cut it in half or divide it by 2. So base times height is 12, but it's half of that. So 6 squares would fill up that triangle, or 6 square units. So let's summarize and put together all of our formulas. These are the shapes that we're going to be looking at this week. So parallelograms, that includes parallelograms, rectangles, squares, and then triangles. So let's start with rectangle, which we've known about for years. It's base times height. But what we saw in these animations is really any parallelogram has an area of base times height. And then we saw that a triangle is half of a parallelogram. So we can do base times height divided by 2. So these would be good formulas to keep handy. You can take a picture of it or write it down. But the good news is there's not a lot of formulas to keep track of. All parallelograms, base times height. If it's a triangle, it's half of that. So what we're going to be moving into in this geometry class, because I'm sure you have found areas in the past, is now we need to look at how do we incorporate all the other things that we've done this year. Pythagorean theorem, special right triangles, trig, all of that stuff. How do we incorporate that into our finding areas? So I didn't put an example with Pythagorean theorem or special triangles in this time, but you will be doing that for your homework. I thought I would throw in an example that involved trig, because that's our newest thing. So how do I know it's going to involve trig? It's because of this 55-degree angle. So if I have a 30, a 45, or a 60, I can use special right triangles. But if I have a 55-degree angle, I need to drop a height to make a right triangle. And the height is what I'm looking for. So I know that this triangle has a base of 18. I want to know what the height is. So I need to have a right triangle if I'm going to be doing trig. It has a hypotenuse of 12. The height is x, and it has a 55-degree angle. And I'm not even going to use the 18 for now because the 18 is the base of the whole triangle, not my little right triangle. So which trig ratio am I going to use? Well, the x is opposite, the 55, and the 12 is the hypotenuse. Some old hippie. Oh, I see it already. It's sine. I'm going to write out the rest also. But I have O and H, so I'm going to use sine. Sine 55 equals x over 12. And then I want to solve for x, so I have to go times 12 to cancel out that 12. And then whatever I do to the right, I have to do to the left also. So in my calculator, I recommend the Desmos Scientific Calculator. We're going to go sine of 55, and then we can go times 12, or 12 times sine of 55. That's about 9.8298. So I think I'm just going to go 9.83. All right, are we done? No, we're not done. That's just the height of the triangle. So the next thing that I like to do is I like to actually write down the formula to make sure that I know what I'm doing. So the area of a triangle is base times height divided by 2. So that's, I'm going to put approximately because we rounded for the height. That's about 18.9 times 9.83 divided by 2. So let's calculate that on a calculator and see what we get. That is about 88.47. And again, there's no units on this, so I'm just going to go units squared, square units. So that's an example of how we might need to incorporate trig in order to find the height of our right triangle. So look out for that. Look out for Pythagorean theorem. Look out for special right triangles. The other thing that we're going to incorporate in some of these problems is some work with coordinates. So it's really important to know how to sketch a graph even if you don't have a grid. So the strategy that we've been showing you all year is just to kind of eyeball where the numbers should go. So P is 6, 11. So I'm not going to make a bunch of tick marks. I'm just going to go over a little bit. That's 6. Up here to 11. And make a P. So it's not going to be perfect, but try to somewhat accurately pick out a location for these points and you'll end up with a pretty good sketch. So A is over 13, but it's still just up 11. So that's a horizontal line segment, which is going to be nice when we're calculating its length. You might even want to do that right now before the graph gets too cluttered. I know how far apart those two numbers are. Okay, the next one is R has an X coordinate of 10, so that's somewhere in between, but slightly closer to the 13. And then a Y coordinate of 2, that's small, so that's down there. And then finally, L is over 3 up 2. So 3, I'm going to go halfway to 6 up 2. So that was R and that was L. And as you can see, you have a parallelogram. We have 2 horizontal segments. And then if we calculated these slopes of PL and AR, they would be the same. So if we want to figure out the area, like I said in the last example, I like to write down the formula. So the area of a parallelogram is just base times height. So we just need to figure out what the base is and what the height is. So the key is to use the correct numbers. So I already highlighted the 6 and the 13 because that was PA. If you prefer the base to actually be on the bottom of your parallelogram, we can use R and L. But you want to subtract whenever you're finding the distance in between two numbers. So 10 minus 3 is 7. That's the base. And then we're going to subtract to find the height too. So we have 11 minus 2. Here's a little pet peeve of mine and Mr. Millington's is we don't want you to write that number next to this slanted segment. We want you to actually draw in a straight up and down height. A height is vertical. So 11 minus 2 is 9. That's the vertical height. If we wanted to see what the length of PL was, we'd have to do Pythagorean theorem. It would be a lot more complicated of a problem. So luckily, all you have to do is subtract, but it's the straight up and down height. That's 9. And then 7 times 9 is 63. So 63 squares would fill up that parallelogram, 63 units squared. So hopefully that gives you a good summary on how to find areas of parallelograms and triangles. And now we're going to practice putting this to work with coordinates, trig, special triangles, Pythagorean theorem, and some basic examples too. So see you back in a minute and let me know what questions you have. Bye.